Hello everyone, I am Piyush Wairale. So in the previous first two lecture, we have discussed what is data, what is database management system, and we have also seen in the second lecture like what are the important steps in database design. Okay, so we have discussed database design process also in the lecture number 2. Now this is lecture 3. In this lecture, we are going to discuss about ER model, right? So ER model is one of the important topic in the database management, right? So we have also discussed at what stage we have to prepare this ER model. So please watch that lecture number 2. It is based on database design process. Now in this lecture, we are going to start with our first topic of our GATE syllabus, that is ER model. Okay. So this is the first slide, that is intro to ER model. So what is ER? What is ER model, right? So ER model is basically a entity relationship model. So E stand for entity and R stand for relationship. Okay. Then we have a different components of ER model. Okay. So apart from entity and relationship, we have one more component, that is attributes. Okay. We have entity, and then we have these relationships. Now attributes are associated with the entity and attributes are associated with the relationships also. Okay. We'll discuss in the further lectures. But attributes are basically a properties of particular entity. Okay, that's you can say. Okay, so generally there are two types of entity. First one is strong entity, and second one is weak entity. Right. So what is strong entity? What is weak entity? We'll discuss. Now the attributes are different types of attributes. First one is key attribute. So what is key? We'll also see that. Just note down this key attributes. Then we have partial key attribute. Then we have multi-valued attribute. Okay. Then we have derived attribute. We have composite attribute. Okay. So yeah, these are the different types of attributes, right? So key attribute, partial key attribute, multiple attribute, derived attribute, composite attribute. Okay. We'll discuss this one by one. Then we have different types of relationships. So generally we call this as a mapping cardinality. So relationship exists between two entities. Okay. So like first mapping cardinality is one to one. It is one to one relationship. Then we have one to many relationship. Then we have many to one relationship. And then we have many to many relationship. Okay. So that's the overall component of ER model. So we have different entities. We have attribute associated with it. We have relationships also. So there are different types of relationship. Or we can also tell mapping cardinalities is also there. Right. And then we have different types of attributes. Okay. So we'll discuss this one by one. Okay, so now what is an entity? So entity is a thing or object in the real world that is distinguishable from all other objects. Right? Say for example, I can say student. Student is an entity, or any person is an entity, like employee is also an entity, or you can say car. Right? Car is also an entity. So any entity is anything or object in the real world that is distinguishable from all other objects. An entity is represented by a set of attributes, right? So So here you can see an entity is represented by a set of attributes. So student is having some attributes, like for example, student is having some name, they are having age, right? Then they are having roll number also, right? Similarly, person is having name, age, right? Then its height, weight, like these are the attributes of a person. Car is having engine number, right? Then we have model, then we have company name. These are different attributes associated with the entity car. Now name is associated with the entity person, right? So these are the different types, different entities, right, in the real world. Now what is an entity set here? Entity set is a set of entities of same type that share the same property. If we consider a student, So if we consider the set of students, say for example S1, S2, S3, these are the three different students, but they are sharing the same properties like name, age, roll number. So then we can say students is a entity set. Okay. Now what is relationship? So relationship is an association among the several entities. Okay. So for example, we have one more entity, say course. The course is having some different attributes. For example, we have course ID is there, then we have credit is there, right? Name is also there. These are different attributes of a course. And now, what is relationship? This relationship is association among the several entities. Suppose we have this student entity, we have course entity. The relationship among the student and course entity it can be represented by a diamond shape, right? So generally, entities represented by a rectangular shape, and a relationship is represented by a this diamond shape. Okay, so we can say student, course. We have two entities, and the relationship say we can give any name, say enroll, right? Enrollment is a particular relationship associated with the these two entities. So here you can say relationship set is a set of relationship of the same types. Okay, similar to entity set. I hope you understand what is entity, what is attribute, and what is relationship. This is a common terminology used in ER diagram. So please remember this. So we have discussed what is entity set, then relationship, then attributes. Now there are different ER diagram symbols, okay, used in a particular ER model. So entity class is represented by a rectangular symbol, okay. So please remember this is IMP. It is important thing because I think in the previous years, like in CS branch, questions has been asked directly from these symbols only. So it is expected that they will ask similar type of question in GATE DA paper also, okay, because this one is easy. You have to just remember it. So this entity class represented by a rectangle. Weak entity class is represented by a double rectangle. Relationship is represented by this diamond shape. Identifying relationship is represented by a double diamond shape. So we'll discuss this what are identifying relationship, weak entity class. Don't worry, we'll discuss. But just keep a note of this particular symbols and what that is indicate, right? Now attributes is indicated by ellipse. Key attributes indicated by ellipse with the line, right? Underline. Then we have discriminator or partial key attributes. So this indicated by ellipse with the dotted line. Then we have derived attribute. Then we have multi-valued attribute indicated by a double ellipse. Then we have composite attribute like this. Okay. So now we'll see what are the different types of attributes. So let us consider one entity, say for example, student only. It is represented by a rectangle, right? So this is rectangle. Assume this is a rectangle. Now the attributes are represented by an ellipse. So say for example, this is roll number, right? And we can draw a single line from entity to attribute represent that this attribute belong to this particular entity set. Similarly, age is an attribute, right? Similarly, name is also an attribute. Okay. Now these are called single valued attribute: name, age, roll number. Or also here we can underline this roll number because roll number is the key here. So what is key? What is the concept of key here? So key is basically attribute or a set of attribute. It is possible that a roll number and age can be a possible combination of a key, or name and age also can be a possible combination of a key. So it depends on the case study. Okay, let us consider is a roll number here in this case because whatever the key will be having unique constraint. So key must be unique in our database. So all the students should have a different roll number, right? So it should be unique and also it should not be a not null. So it should not be a null value here. So every student should have a particular roll number, right? That is what our database will ensure. So what is key? So key will uniquely identify each row in a table. Okay. So for example, just consider we have a student, we have his roll number as an attribute. Now this attribute is a key here because it will uniquely identify each row in a table. So if I know the roll number, I can give all the information of that particular student because that is unique, right? So it can be attribute or set of attribute also, right? Attribute or set of attributes. So don't worry, we are going to have separate video on the key. So it's a very important concept. We will discuss in the further lectures. So we will be having separate lectures on the key itself. So as of now, just remember, so key can be attribute or set of attribute, and it should be a unique. And so show that it should uniquely identify each row in attribute, right? So this is an entity represented by a rectangle, and the attributes are represented by an ellipse. So this underline will give us attribute, right? Now what is composite attribute here? We have discussed composite, right? So this is basically a key attribute, right? Key attribute, right? And this age name is a single valued attribute, okay? You can see the single valued attribute. Now what is composite attribute? We'll see. So composite attribute is represented like this, right? So this is, we have one parent attribute, then we have this its component, right? Like this, different types of components like this. Okay. So for example, we have address, right? So address is a composite attribute having different components, like we have pin code, right? We have street number, right? We have landmark also, right? Or you can say, for example, our full name, right? Full name can be also considered as a composite attribute if they are having three components. So what are the three components? That is first name, then we have middle name, then we have our last name, that is surname, right? That is surname. So if we are storing first name, middle name, last name in three different column or three different attribute, we can say, then we can say this full name is a composite attribute, right? Or if we are just storing our full name in a single particular row, then it is just our single valued attribute, right? It's a full name, that's it. It depends on case to case study. So what are the configuration of a database? It depends on that. But address can be have multiple components like pin code, street number, landmark. So we are storing three different attributes. So these are this is the example of composite attribute. Right? Now we have seen derived attribute also, right? So let's see what is derived attribute. So what is derived attribute here? The attribute whose value is derived attribute whose value, or you can say a field, is derived from other attribute, right? Other attribute. For example, okay, so derived attribute is represented by an ellipse, dotted ellipse. So for example, age is a derived attribute. Okay. Suppose we have a student entity here represented by an rectangle, and this is our attribute. Okay. Now this age attribute is derived from a stored attribute, that is date of birth. Right. A student is having date of birth, it is stored attribute, and age is a derived attribute. Right. So we are not creating a separate for age attributes. We are deriving this attribute from a date of birth. Right. So that's what derived attribute is. So this attribute is depend on the date of birth attribute. That's why it's derived attribute and represented by a this particular dotted ellipse. Now we have multi-valued attribute, right? Multi-valued attribute. Suppose it is represented by a double ellipse. Okay, this is double ellipse. Consider this double ellipse. This multi-valued attribute. For example, phone number, right? Now student or any employee can have multiple phone number. So suppose we have one column here, phone number in our database, right? So what is multi attribute will, so what is multi attribute? If we are storing or both the roll numbers in a particular cell only in a one cell, only in a one field like this, okay? Suppose again we have this whole number, again we are having this one more number, okay? But we are storing both the four number in a particular cell only in a single field. So that's what it is multi-valued attribute. Okay. So this is not recommended in a database because we can't update this phone number, right? So we'll discuss this in the when we are going to discuss about the normalization form. As of now, just note down that multiple attributes indicated by a double ellipse. So this is the example. Like student can have multiple phone numbers, right? It is storing in a single field. So I think that's what we have discussed. So initially we have discussed about composite attribute, derived attribute, multiple attribute. Then we have roll number is a key attribute, right? Yeah, so I think we have discussed about entity, relationship, and different types of attributes. Okay, and we have also seen what are the different components of a ER diagram, and this is a different symbol. So please note it down. It is very important. This slide. Okay. Now we'll discuss about the mapping constraint. Okay. Here you can see mapping constraint, or we can also call it as cardinality. Okay, mapping cardinality. Both are the same thing. Now many to many relationship. So here instructor can have many students and student can have many instructors. Okay, for example, we have two entity like this. Okay, course and this side is student, right? S1, then S2, then S3. Here's instructor 1, instructor 2, instructor 3, instructor 4. The instructor is having multiple students, so it's teaching to S1 also, S2 also. Now I3 is teaching to S1 also, S2 also. Similarly, S2 is for S2, both I3 and I1 is are the instructors. Huh? It is many to many relationship. So on both the side, they should have at least two uh, mapping, right? That is many to many relationship. That instructor can have many students, and student can have and student can have also many instructors, and it's represented by a single line only. Okay, there is no arrow in between. Now, if we see about this one to many relationship, this arrow indicates one. Okay, so here on this we can say n, and this is one. Here both the side we can say n. Okay, it is n is to n, and here 1 is to n, right? So arrow indicates 1. 1 here is at most 1. Okay, not exact 1, not at least 1, it is at most 1. Means 0 is also possible. Same example, let us take instructor 1, instructor 2, instructor 3, and here also we take example like student 1, student 2. Okay, so now in this case what will happen, instructor can have many students, so I1 can have S1, I1 can have S2 also, but it's not the reverse. Like S2 cannot have I2 or S1 cannot have I2 because it will become many to many relationship there. Now from this side, from student side, it is many to one. But when we read from an instructor side, it is one to many relationship. Okay. So in one to many, what happens? Like where each entity can be related to a more than one entity in a particular relationship. Right? Now, if we have this S3 also, then I2 can teach S3 like this, right? But S2 can't have an instructor S1 or like I2 or I3. This is one to many relationship. Similarly, many to one relationship, like on this side we have instructor, say I1, I2, I3, say I4, and this side we have student, say S1, S2, S3, right? So it's many to one, right? So many instructors, I2 is teaching S1 also, and I1 is teaching S1, and I2 is teaching S1 also. Similarly, I3 is teaching to S2, and I4 is teaching to S3, right? So that's what many to one relationship, right? So many instructors are teaching a particular one student, right? So S1 is now from student side, it is one to many relationship, right? So for a particular student S1, it's having many instructors. Same for S2, right? This is what many to one relationship. Now one to one relationship is simpler. This arrow is indicate one. It's at most one. Here also one. So it is 1 is to 1. Here it is n is to 1. Right. Similarly, instructor can teach at most one student, and student can have at most one instructor. Right. Say for example, again we are representing I1, I2, I3 as the instructors. Then we have S1, S2, S3. So each students are having only one instructors and instructors having only one students. Right? So that is at most one. So I3, I4 can be and I4 may not be associated with any student. So that is also possible because it is at most one. That is what one to one relationship is. Now, one more thing is that about total and partial participation. So, whenever there is a single line, you can see this partial participation, and when there is a double line, it will indicate total participation. Right. So, what is partial participation? What is total participation here? Suppose let us take the same example. Okay, we have this instructor entity, say I1, I2, I3, and we have student also here, right? That is S1, S2, S3. So what is total participation here? Like each entity in a set particularly, because we are having from student side, so each entity in this particular set must participate in the relationship, right? So for example, in the previous case, if it is S4 is don't have any instructor, that is also fine. Like here also S4, that is also fine if you don't have any instructors. But here every student must have an instructor. So S1 should have I1, S2, I2, or S3 I2 or S3 I3, anything can be possible. Every student will have some instructor. That is what total participation is. So each entity in an entity set must participate in the relationship. Right? So that's about the total participation. And what is partial participation? The entity in the entity set, like for example, our instructors may or may not participate in the relationship. For example, we have one more instructor, say I4, and I4 is not associated with any student. So that is partial participation. Here you can say all are partial participation. But here you can see we have indicated double line. So double line indicates the total participation, means every student must participate, must have instructor, right? Must participate in this relationship. So must have advisor as an instructor, right? So that this is what total and partial participation is. So I think let me know if you have any doubt up till now. You can just comment below. I will reply to that. So that is about the mapping constraint, right? So we have discussed what is entity, what is attribute, what is relationship, different types of attributes, here diagram symbols, and relationship. Okay. Now, one more thing is that about the strong entity and weak entity. So, first one is strong entity. Okay. Then we have weak entity, right? So, what is strong entity? Basically, an entity. So, strong entity is generally represented by a rectangle only, right? And weak entity is represented by a double rectangle. Okay, like this. Okay, so what is strong entity here? So like it is a type of entity that has a key attribute. So this strong entity will have a key attribute. Okay, so this attribute is enough to uniquely identify each row in this particular entity, right? This is a key attribute. This is a key attribute of this particular strong entity. So this strong entity does not depend on any other entity. So one main feature is that the strong entity does not depend on other entity for their existence, right? So student or any employee can exist entity, that is a strong entity because it is independent of any other entity. So we'll discuss one example also. Now what is weak entity here? So weak entity is associated with a partial key, that is ellipse indicated by a dotted line. Now this partial case attribute is used to uniquely identify each row in a particular weak entity, right? So for example, let us take one example. We have the employee, right? We have employee, and this is an entity, right? And once we go to the any company, join as an employee, so company will give us the insurance, right? Insurance, right? When we are applying for insurance, we need to give nominee also, right? Nominee also, because while filling the insurance form, we need to give nominee also, right? So nominee can also be a part of one entity, right? So nominee, what I am saying, it is a entity, right? And we have a relationship between this is insurance policy. Okay. Now what I'm saying, This nominee entity exists only when there is an employee, right? Only when employee purchase an insurance, then only this nominee will come, right? Because nominee cannot exist by own. It is not possible that we are having a nominee, but we don't have a corresponding insurance for insurance employee for that, right? So this insurance nominee will exist only when someone take the insurance, right? So that is what weak entity set is. This is a weak entity set. So nominee is a weak entity set because it's completely depend on this particular employee. If employee didn't purchase this insurance policy, then how will nominee become? Right? So that is what each entity, that is what weak entity set is, and it is represented by total participation. Because what is total participation? If you remember, every entity associated with this particular weak entity must have a association with other entities. So like every nominee must have a particular employee, right? Every insurance policy it must have, right? So this is what it indicated by total participation. Now, what is weak relationship? Weak identifying relationship. We also discussed something like weak identifying relationship, right? That is weak identifying relationship, right? We have discussed this, and it's represented by a double diamond shape, right? Now, weak identifying relationship exists only when there is weak entity. Okay. Now, this weak identifying relationship is associated with the weak entity only. So here we are having the weak entity, this one, this nominee, because it cannot exist without employer, without insurance policy. So this insurance policy will also become weak identifying relationship, and we generally indicated by a double ellipse. Sorry, double diamond shape. So this is what weak entity is. This is what weak identifying relationship, and this is a strong entity. This is a total participation. There is a partial participation because employee, there will be employee who don't have any insurance policy, right? But if they are having the insurance policy, it means they are having the nominee also, right? So I hope you understand the concept of strong entity and weak entity. So I think that's it from this today's lecture. So we have discussed about what is entity, what is relationship. Then we have discussed about the attributes, different types of attribute, different types of entity. We have also discussed the symbols, right? And we have also discussed the mapping cardinality. Okay. So if you have any issue, please you can comment below. Okay. Any doubt, you can comment below. Thank you.